Welcome everyone. In this video we're going to go through an A-level chemistry exam question on shapes of molecules. Details are in the description. Let's get started. Here's the question. Ammonia reacts with aluminium chloride as shown by the equation NH3 plus AlCl3 goes to H3n AlCl3. Draw diagrams to illustrate the shapes of NH3 molecules and of AlCl3 molecules. Including your diagrams any lone pairs of electrons that influence the shape. Indicate the values of the bond angles. Covalent bonds usually occur between non-metals. However, aluminium, a metal, forms covalent bonds in some compounds. We are told in the question that molecules are present. You should be aware that covalent bonds occur between the atoms in molecules. Another metal, beryllium, also forms covalent bonds in some compounds. To answer this question, you first have to look at the number of lone pairs and bond pairs around the central atom in each of the molecules. A dot and cross diagram might be useful to help you identify the number of lone pairs and bond pairs, but as you gain more experience, you should be able to answer questions like this without dot and cross diagrams. Nitrogen is in group 5. There are 5 electrons in the outer shell of the nitrogen atom. These are shown with crosses. There is 1 electron in the outer shell of each hydrogen atom. These are shown with dots. A pair of electrons is shared between 2 atoms in a covalent bond. Shared electrons are shown where outer shells overlap. These are called bond pairs of electrons and are highlighted in yellow. There is also a pair of electrons on the nitrogen atom that is not in a covalent bond. This is called a lone pair of electrons. When atoms bond covalently, electrons are shared so that each atom gets a full outer shell of electrons. This is sometimes called a noble gas configuration. There are some exceptions to this and we will look at one of these later. There are now 2 electrons in the outer shell of each hydrogen atom, a dot and a cross. There are 8 electrons in the outer shell of the nitrogen atom, 3 dots and 5 crosses. All 4 atoms have a full outer shell of electrons. In the case of hydrogen, remember that a maximum of 2 electrons will fit in the first shell. Electrons have a negative charge. Pairs of electrons repel each other. Electron pair repulsion theory is used to predict the shape of molecules. Bond pairs of electrons lie between 2 positive nuclei. The lone pair of electrons is only attracted to 1 nucleus. Electron pairs repel, but lone pairs repel more than bond pairs. The diagram in the centre illustrates the shape of this molecule. The yellow sphere at the top represents a lone pair of electrons, the pink sphere in the middle is the nitrogen atom, and the white spheres represent hydrogen atoms. It is not always practical to show diagrams as artistically as this. Wedge and dotted line notation must be used to represent the 3-dimensional shape of molecules in exams. The 3-dimensional diagram for ammonia is shown on the right in blue. A wedge represents the bond coming out of the plane of the screen. A dotted or dashed line shows the bond going into the plane of the screen. A solid line shows the bond in the same plane as the screen. And finally, the lone pair of electrons must be shown as 2 dots above the nitrogen atom. You have to memorize certain shapes and bond angles. There are 3 bond pairs and 1 lone pair of electrons around the central atom. If there were 4 bond pairs of electrons, they would repel equally, giving a tetrahedral shape and a bond angle of 109.5 degrees, a very important shape to remember. However, lone pairs repel more than bond pairs, so the bond angle is reduced by 2.5 degrees. The bond angle here is 107 degrees and the name of this shape is trigonal pyramidal. Let's move on to aluminium chloride now. Aluminium is in group 3 and has 3 outer shell electrons, shown with dots. Chlorine is in group 7. Each chlorine atom has 7 outer shell electrons, shown with crosses. Although aluminium only has 6 electrons in its outer shell, this configuration is stable. We can think about this in a couple of ways. Aluminium is a small atom. It would be difficult to fit more electrons into the outer shell of this atom. Also, of the 4 atoms present in one molecule, 3 of them, the chlorine atoms, now have a full outer shell. To work out the shape of a molecule, we only have to consider the number of lone pairs and bond pairs around the central atom of a molecule. There are 3 bond pairs of electrons and 0 lone pairs of electrons around the central atom in aluminium chloride. The diagram in the centre illustrates the shape of this molecule. The pink sphere represents the aluminium atom and the white spheres represent the chlorine atoms. A model of this molecule would lie flat on a desk with each atom touching the desk. In this case, wedges and dotted lines are not required. The diagram on the right in blue is the 3-dimensional representation needed to answer the question. Bond pairs of electrons repel equally, leading to a trigonal planar shape and a bond angle of 120 degrees. The full answer to the question is given here. Thanks for watching, and I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.